I would like to start with the medical device regulation, obviously. And as you guys probably all know, there is nothing written about AI. So we have to search what could be related most to AI. And this is obviously everything which has something to do with software, obviously. And the most known, well-known sentence inside the MDR, that's Annex 1, I think 70.3 or 70.2, says whenever you have a device which is software, which contains software, we have to develop that state of the art and also care about development life cycles, risk management, IT security, and verification and validation. I would like to dive a little bit into this verification and validation part. And this means that you know what you are validating for. And this is not as easy as it looked like. For example, if you would have a system, one system makes the predictions in 99.99995% correct, and in the other case, 92.1761, yeah, whatever the numbers are. So that's basically the accuracy. And if you asked, I would say most of the auditors, which is the better system, they probably would say the first one. And this could be completely wrong. And I would like to explain that on an example. I again use not a medical example, but an example from fraud detection. Yeah, think about you have, let's say, you are evaluating a credit card transaction, for example, and there are 1 billion transactions, and just 5 of them are fraudulent. Yeah, that's the ratio between fraudulent and valid transactions. And now you can write a very easy algorithm which fulfills basically our accuracy requirement. And I show you now the code. This is the code. Always you just return, if the question is that transaction a fraudulent transaction, you always return false. And then you are correct in 99.9995%. Yeah, but this is completely worthless. In other words, already picking accuracy as quality metric is the wrong choice, especially if you have such asymmetric constellations. So a very important lesson learned is here. You have to derive from your medical purpose the right quality metric. And in this particular situation, accuracy would be the worst pick you can make. Most probably sensitivity would be more helpful. So this is what we observe very frequently, that we have, I would call it a bottom-up approach. Now you have developers, they have data, and then they try out what they can achieve with this data. And basically the result, what they can achieve, the best value they can achieve, they pick them then to be their quality metric. But you have to make a top-down approach, going from intended use to quality metric, and not vice versa, from data to quality metric. Joko was asking me, give us a short rundown, when do we need a clinical investigation? And my hint would be the following. So what you always have to have is obviously clinical data. And if you have not enough clinical data, you obviously have to collect this data. If you have enough clinical data, then you should decide whether they are sufficiently equivalent. If not, you again have to collect it, and only if you have enough clinical data, then you can basically evaluate this data and decide whether your product is safe, performant, and actually reaches the intended use. Now the question is, when are data sufficiently equivalent? And sometimes I hear the notion of, yeah, the algorithm must be exactly the same. And this is not quite true. We have in an MDCG document let's say the short sentence that this is not even reasonable to demand that. But they do not describe what is enough in that particular case. And MDR says the equivalence, also the technical equivalence, must be demonstrated, and this explicitly includes the algorithms. And the result is a little similar to what Oliver just described. We have, as of now, no common practice when are two algorithms sufficiently equivalent in terms of models. Sometimes auditors say, yeah, it's basically the same model. Okay, if you get through with that, that's also fine. But the same model typically does not mean that you get the same results, since if you have this bazillion of parameters to be fitted, you can have completely different outcomes. if you compare things, and if you are afraid of, do we really now have to make a clinical investigation, we should think about, okay, what do you actually have to prove? And in another MDCG document, they say, what are the aspects to be evaluated? And there are 3 different aspects: clinical association, technical performance, and clinical performance. And for example, technical performance, you typically do not need any clinical study at all or a clinical investigation. Rather, for clinical performance, clinical performance means, is the intended purpose in the intended clinical context for the intended patients actually being achieved? And here, clinical investigations are one mean, but in frequent cases, it's also possible to use retrospective analysis of existing data. But in any case, regardless, you have to prove that your data are sufficient and that your data are sufficiently equivalent, which is not a problem if you test it with your own algorithm, but you have to prove it also in the same clinical context, since there's not only the technical equivalence, but also the clinical equivalence.